I think I can start. Yeah, so good morning to us all once again. Today we are going to study probabilities, okay? We are going to study probabilities again this morning. Now, this will be the outline of the presentation. First of all, we hope that at the end of this meeting, we would understand the concept or the idea behind probability. Then we should be able to know certain terms in probability. Then we should be able to apply probability in examining business situations. Then understand the various approaches to probability, and then also know how to employ the probability tree, understand the Bayes theorem, and then evaluate random variables, then compute expectation on investment return. So at the end of this meeting, we hope to So at the end of this meeting, we hope to actually finish up to here where it says compute expectation on investment return. All right, so that in the subsequent meetings, we would continue with compute Poisson, binomial, hypergeometric. So the last 5 topics, like here, the last 5 topics will be done tomorrow, God willing. And then all the rest will be done today. So let's really pay attention. Now, yes. So now, when we talk about probability, okay, we are simply referring to how probable or the likelihood of an event happening, all right? So when we're talking about probability, we are talking about the likelihood that an event will happen, okay? Now, if I want to probably examine, let's say, the likelihood that all of you will come to campus on the day of reopening, okay? It's just a likelihood or it's just a chance, all right? So if I want to examine the likelihood that all of you will come to campus on the day of reopening, I'm just examining probability. So somebody can just say, it is probable that all of you will come to campus. It is probable that 70% will come to campus, or somebody can even say there is 60% chance that all of you will come. Maybe there is 40% chance that all of you will come. And these things are very essential in business because as a business person, you should be able to estimate or know the likelihood of an event happening. So the idea, the concept, or the theory behind probability is to examine the likelihood of an event happening. Okay. Now, in terms of percentages, okay, if you are totally certain that the event will happen, it means that the probability will be 100%. All right. And if you are totally certain that the event will not happen, then it means that the probability will be 0%. So I'm saying that if you are certain that an event, so if you are totally certain that an event will occur, the probability will be 100%, okay? Those of you, who know percentages, 100% simply means 100 over 100. That's 100%. It means 100 over, which is 1, okay? Then, if you are also totally uncertain that an event will occur, it means that it's 0% or it's 0, right? So then this simply tells us that probability, yeah. Okay, somebody's okay, so here, if you are totally uncertain that an event will occur, it means that the probability is 0%. Now, this therefore tells us that between the range of 0 to 1, that is in terms of decimal, because, or in terms of values, like absolute values, not percentages. If you want to do percentage, it means that between 0% and 100%, okay, it tells the extent or the likelihood of the event happening. So if you have a probability of, let's say, 60%, which is the same as 0.6, actually, that's 60% is 60 over 100. Okay, this tells us that the likelihood that the event will occur is 60%. That means that if somebody also have a probability of, let's say, 80% or 0.8, it means that this person of 0.8 is more certain than that the thing will occur than the person who has a probability of what? 0.6. All right. And somebody has a probability of 0.6 is more certain than somebody who has a probability of 0.1. Okay. So those are the issues that we have to pay attention to. All right. So probability just tells the extent or the likelihood of an event happening. Okay. If probability is, let's say, 0.1, it doesn't mean that the thing will occur or the thing will not occur. It just tells the likelihood. Somebody's asking what topic is this. Please, we are doing probability. That is the issue. So here, it means that there can be a probability of 0.1, but that thing can still occur. Even the probability can be 0.0001. It can still occur. Just that the likelihood of it occurring is very low. All right. So the fact that we have a low probability doesn't negate the fact that the thing can occur. It can occur, but then the likelihood of occurrence is very low. The likelihood of occurrence is very low. All right. So that is it. Now, how do we compute probability then? So probability is the total likely ways in which, and so here, probability is equal to number of A over number of S, all right? Which is the number of A is the number of ways that an event A can occur. Then the number of S is the total likely ways an event can occur. And let me explain that. So here, what we are saying is that probability, okay, of, let's say, an event A is the number of times or ways A can occur over total number of likely ways. Okay. All right. So here, let's say in a class of 30, in a class of 30 students, okay, let's say 6 are female and the rest are male. All right. If a student is selected at random, okay, if a student is selected at random, find the probability that find the probability that the student is, let's say, I, male, I, female. All right. Now let's watch this scenario carefully. In a class of 30 students, 6 are female and the rest are male. If a student, so look at the preamble. If a student is selected at random. So the preamble says that if a student is selected at random, if a student is selected at random, if a student is selected at random. Now, it means that the total likely ways, like if I want to choose a student random, the total likely ways that this can occur is 30. It means I can choose any student at all, right? So the total likely ways that this can occur is 30 because the question says that if a student is selected at random, so the total number of likely ways is 30. Then it says, find the probability that the student is male. Okay, so the number of times or the number of ways that male can occur is 24 because there are 30 students, 6 are female, the remainder, which is 24, are male. All right, so the number of ways that male can occur is 24, but the total number of likely ways of selecting a student at a random is 30. Okay, so the probability of male will be 24 over 30. That means that the probability of female will be 6 over 30. All right, will be 6 over 30. Will be 6 over 30. Okay, let's take another scenario. All right. Now, another scenario here is that, let's say in a, let's say in quantitative, let's say in quantitative methods class, all right, there are 300 students, or let's say 200 students, okay, out of which, so there are 200 students, out of which 120 are finance, okay, and the remainder is beard management, and the remainder is beard management, and the remainder is beard management. All right. Now, there are 70 male finance students, all right, and 50 female beard management students. All right. So let's look at the question. If a student is chosen at random, okay, find the probability that the student is finance student, finance student, if a student is chosen at random, find the probability that the student is a finance student, a beard management student. Okay. Now let's look at this question. In a class, there are 200 students, out of which 120 are finance, and the remainder is beard management. There are 70 finance students and 70 male finance students and 50 female beard management students. If a student is chosen at random, find the probability that the student is a finance student or a beard management student. Now, questions like this, you are supposed to draw a table, because once you don't draw the table, it makes following the argument very, very difficult. All right. So here, there are a class of 300 students, right? We have finance, we have beard management. So finance and then beard management. Yes, so the question says that in a class of 200 students, there are 120 finance, right? So we have finance, then we have male, and we have female, okay? So once you draw the table, it makes it easier for you to do the analysis. So the total finance students we have is 120, right? Then the question says the rest are beard management, so 80, because we have a total of 200 students. Now, the question says that there are 70 male finance students and 50 female beard management, okay? So 70 male finance students. So finance, we have 70 male. That means that the remainder of 50 will be female for finance. Then for beard management, we have 50 female, right? That means that the 30 male will be here. So it means that the total of male is 100. If you cast it along this line, then the total of female is 100. Okay, yeah, it's 100. Okay, so this is the table. Then the question says that if a student is chosen at random, find the probability that the student is a finance student. So the preamble is if a student is chosen at random, if a student. Okay, so if a student is chosen at random, so let's say probability of finance, right? If a student is chosen at random, it means you can choose any of the 200 students. So the total number of likely ways, the denominator will be 200. But then the question says that if a student is chosen at random, find the probability that the student is finance, right? So finance, they are a total of 120. So we have 120 over 200. Then you get your answer. Then find the probability that the student is from beard management. So as I said, the preamble is that if a student is chosen at random, so the denominator, it will be 200 because any of the students could be chosen at random. But what is the probability that a person is beard management? Then the likelihood of selecting beard management is rather 80, all right, which will be the numerator, okay? So these are some of the simple ways that we can solve probability. Now let me add a little twist to the question. So those of you having calculators, you can just punch this and write the answer. Punch this and write the answer. Now let me do a little bit of twist to the question. Now if the question rather says that if a finance student is chosen at random, okay, find the probability that the student is a female, okay. Now let's watch this space. The preamble says that if a finance student, if a finance student. Okay. So what do you think will be the denominator? You can type in the comment section. What do you think will be the denominator? If you have this preamble that says that if a finance student is chosen at random, what will be the denominator? Okay, somebody says 120. Okay. All right. So, of course, so if the preamble says if a finance student is chosen at random, it means that the total number of ways of selecting a finance student, which is what, 120, will be the denominator. Find the probability that the person is a female. So the likelihood of selecting a female rather is 50. All right, so that would be the numerator. Okay, so let's pay attention to some of these things. Always watch the preamble. Always watch the preamble if a finance student is chosen at random. All right, now let's do this and then we move on. So that was the question. I mean, for those of you who couldn't write, that's the question. Okay. All right. Now let's do a little twist in the question. Now, if the question says that if a student, okay, if the question says that if a student is chosen at random, find the probability that the student is a female beard management. Find the probability that the student is a female beard management. Okay. Find the probability that the student is a female beard management. The question says if a student is chosen at random, okay, find the probability that the student is a female beard management. Okay. Now the preamble says that if a student, so it means that the denominator will still be 200. Okay. But female beard management, they are 50. Yeah. So female beard management are 50 people. So it will be 50 over what? 200. I think you get 0.25. That's 1/4. All right. So those are the issues that we must pay attention to. All right. So I believe we all have some form of basic understanding when it comes to probabilities now. Okay, so let's move on. Now, going forward, what is the relevance of probabilities? Yeah. Somebody is asking what we are doing, is it the same? The essence of a probability in business decision, it helps us to tackle the investment problem. It helps us to introduce a new product because this is important because probabilities will help us know the likelihood of that product surviving on the market. It also helps us in customer service because probability would help us predict customer behavior, right? Predict customer behavior. It also helps us in scenario planning because probability will help us create scenarios, look at the likelihood of certain issues happening and looking at the likelihood solutions, all right? So probability is just about likely, and that is how we apply it in business. Okay, so, ooh. Okay. Yeah. Okay, so yes, and these are some of the basic terms in probability that we must pay attention to because we are going to mention those terms as we move forward. Now, when we say a trial, okay, a trial in probability is any process which, when repeated, generates a set of observations. All right. So if I close my eyes right now and or if I look at the list of participants right now on the Zoom call, and I just mention any name at random, it's a trial, because it's a process. When I repeat it severally, I'll get results. So when I mention a name, I'll get somebody. When I mention another name, I'll get somebody. So, for instance, selection of a student at random from a class is a trial. Now, whenever we embark on a trial, we generate a set of results. So when I want to choose somebody at random and I get the person, it's a result, because it's the outcome of carrying a trial. So the outcome is simply the possible results of carrying out a trial. Okay. An outcome is the possible results of carrying out a trial. Then also we have an event. An event is specifically defined outcomes that is of particular interest to the person doing the trials. So then, when I want to choose a student from the class, it's a trial. The outcome is that I'll get a student. But when I want to specify that I want to choose a student, but I want a male finance student, then it's an event, because I have specifically defined the outcome I'm expecting. So that makes it an event, all right? Then the set of all possible outcomes, that is usually the denominator. When it comes to probability, that is the denominator. That is the sample space. That is the sample space, all right? There are several approaches to probability. You have the objective probabilities, the subjective probabilities, and then the empirical probabilities, which you would have to read in detail. Now let's go to the types of probability events. Types of probability events, all right? Now we have several types of probability events. One of them is the mutually exclusive event. One of them is the mutually exclusive event. Mutually exclusive event. Mutually exclusive event. Now, I like to teach this normally using a Venn diagram. I like to teach this normally using a Venn diagram. So here, yes. So, yeah, so here, if we have, let's say, let's say, we want to choose a probability of an event A, all right? So let's say probability is probability of an event A, okay? And let's say this is the probability of an event B, okay? All right. Let me give this scenario. I think you understand it better. Now, are you aware that if I want to choose, like in the total class of quantitative methods, finance plus BN management, if I want to choose a female at random, the female could be a female finance or a female beard management. So the female can be a female finance or female beard management. All right, a female finance or a female beard management. Now, when it happens like that, those events are not mutually exclusive. Now, mutually exclusive event is an event where two things cannot occur at the same time. So a simple example of a mutually exclusive event is choosing a finance student from a quantitative methods class, because when I'm choosing a finance student, there is no way the finance and beard management will occur at the same time. All right. So let's say we have two events, probability of A and probability of B. And where this one here, the intersection, is the probability that A and B will occur together at the same time. Okay. Now, it means that probability of A or B is equal to probability of A occurring plus probability of B occurring plus probability of A and B occurring. All right. Oh, sorry. And minus probability of A and B occurring. Sorry. Minus probability of A and B occurring. So what I'm saying is that if probability of A or B occurring is probability of A, because in probabilities all means addition, plus probability of B, okay, minus probability of A and B. Now, the reason why we subtract probability of A and B from this scenario is that you are saying probability of A or B occurring, probability of A or B occurring. So there's no way they should occur at the same time. That is why we subtract the probability that the two of them are occurring at the same time from this, all right? But when two events are mutually exclusive, what happens is that there is not even any intersection. Mutually exclusive means that when this happens, this will not happen, all right? So for mutually exclusive event, probability of A or B is equal to probability of A plus probability of B minus 0, right? Minus 0. Reason being that because it's mutually exclusive, the two of them cannot occur at the same time. So because it's mutually exclusive, probability of A and B occurring is 0. Like this section is 0 here. Because they can't occur at the same time. So here is 0. So in essence, what I'm trying to say is that in summary, probability of A union B for mutually exclusive events is equal to probability of A plus probability of B. All right, and that is it. Probability of A plus probability of B for mutually exclusive events. So that is it about mutually exclusive events. Okay, so for mutually exclusive events, probability of A union B is equal to probability of A plus probability of B. All right, that is it for mutually exclusive events. Okay. All right. So let's look at this example. In a race, the probability that Asibe wins is 1/3. The probability that Mugabe wins is 1/4. The probability that Safo will win is 1/5. Find the probability that Asibe or Safo wins, assuming both events are mutually exclusive. All right. So probability of Asibe or Safo winning is probability of Asibe, which is represented by probability of A, then probability of Safo winning, which is represented by probability of S. So we have probability of A plus probability of S. So that's 1/3 for Asibe here, then 1/5 for Safo here. Then we get our answer. Okay. Then the question also says that also find the probability that neither Asibe nor Mugabe wins. Yeah. Oh, okay. Yeah. So find the probability that neither Asibe nor Mugabe wins. Okay. Now I didn't mention this earlier, but let me mention it now. I didn't mention this earlier, but let me mention it now. Okay. So let's watch this space. Now, let's say this is total, this box here is total probability, where we have A here, we have B here. Oh, the names are Asibe, sorry, so let me use that. So the names are Asibe, Safo, and let's say Mugabe, all right? Now, probabilities, as I said, those of you who joined earlier, probabilities ranges between 0 and 1. So there's no way you calculate probability and you get more than 1. It's wrong. And there's no way you calculate probability and get negative. It's wrong. Okay. Now, if I want to find probability of A, this is probability of A, right? But if I want to find probability of not A, so if I want to find probability of not A, okay, please, the probability of not A, we denote it by a bar on A. So probability of not A is probability of like this, with a bar on top of A. So that's probability of not A, okay. Now, reasonably, because probabilities sum up to 1, okay, reasonably, because probabilities sum up to 1. Just a moment, please. All right. Yeah, sorry about that. So here, probability of not A, all right, reasonably, if probability should sum up to 100, and let's say here is 20, okay, probability of A is, let's say, 20%. This simply means that probability of not A will be what the remaining 80%. All right, this is mathematical sense. All right, the probability of not A means all the rest, which will be 80%. So probability of A, if probability of A is this, probability of not A will simply be 1 minus probability of A, which is 1 minus the 20%, that's 0.2, you get 0.8 for all the rest, all right? So that is the issue. So that is it. So anytime you want to find probability of not something, it means that it is 1 minus probability of that something, okay? If you want to find probability of not something, it's 1 minus probability of that something, all right? Okay, so here, the question says that also find the probability that neither Asibe nor Mugabe wins. Also find the probability that neither Asibe nor Mugabe wins, all right? Now, Asibe winning is 1/3, Mugabe is 1/4, okay? So if you want to find probability of neither Asibe or Mugabe winning, it means that you have to find probability of either Asibe or Mugabe winning, all right, which is 1/3 plus 1/4. So this will give us either the two of them will win, all right? Either the two of them, Asibe or Mugabe, all right? Either Asibe or Mugabe wins, all right? Either Asibe or Mugabe wins. It's 1/3 plus 1/4, okay? Yeah, those of you with calculators, what do you get? 1/3 plus 1/4. 1/3 plus 1/4. You can just type in the comment section. Okay, so 7/12, right? So that is 7/12, all right? So neither, the question says, neither Asibe nor Mugabe wins. But we have found either Asibe or Mugabe wins. So if you want to find the other side, neither, it means that it is 1 minus either Asibe or Mugabe wins, okay? That would be 1 minus 7/12. Then you get, I think, 5/12, okay? I think you get 5/12. So that is it. So always when you want to find the other side of probability, just subtract the one with the side you have from 1. Okay, just subtract the side you have from 1. Okay. Yeah, so there's a question here. Please, would it be the same if we add? Please, will it be the same if we add looked for? Oh, I don't get it. Please, would it be the same if we are? The English is not making meaning to me. All right. So let's move on. Okay, so let me look at the question again, what somebody is asking. Yeah. Oh, what is happening? Yeah, so the person's question is, will it be the same if we are looking for the probability of losing individual and adding them? Yeah, so here we have 5/12. Exhaustive events. So now we have to run a little quickly. So a group of events are set. So we are done with mutually exclusive events. All right. So the next type of probability event is exhaustive event. Now, when we say a probability event is exhaustive, what it simply means is that they encompass all possible outcomes from the experiment. All right. They encompass all possible outcomes from the experiment. They encompass all possible outcomes from the experiment. So the example we just did, we have probability of Asibe, which is 1/3, probability of Mugabe, which is 1/4, probability of Safo, which is 1/5. Okay. Now let's say probability of A plus probability of B plus probability of M plus probability of S. All right. So we have 1/3 plus 1/4 plus 1/5. Those of us with calculators, can we quickly punch this? 1/3 plus 1/4 plus 1/5. 1/3 plus 1/4 plus 1/5. Okay, so we are having 47/60. So we have 47/60. All right. That means that, so 47/60. That means that there is a remainder of 13/60. If you add it, you would have gotten 60/60, which is what? 1. So it means that there is still a probability left to make this up to 1. So these 3 events are not mutually exhaustive. They are not exhaustive because it means that there's one more, or there are several other probabilities, so that when you sum everything, you should get 1. So probabilities are exhaustive when you sum them, they should be equal to 1. All right. Once you sum them and they are not equal to 1, it means that they are not exhaustive. They are not exhaustive. That means that there are some other probabilities of other people winning. All right. Okay. So let's look at this example. If the probability that Asibe winning is 1/2, the probability that Mugabe winning is 1/4, and Safo winning is 1/4, when you add these, 1/2 plus 1/4 plus 1/4, you get 1. So if these are rather the probabilities, if that's 1/2, 1/4, 1/4, if they are the probabilities, then they will be mutually exhaustive. All right. But once they are like what I did, like here, 1/3 plus 1/4 plus 1, you will not get 1. So this, when they are this, they are not mutually exhaustive. But once you sum them up and they are equal to 1, then we can confidently say that they are mutually exhaustive. Okay. We can confidently say they are mutually exhaustive. All right. So those are a mutually exhaustive event. Then you go to independent events. Independent event. All right. So independent events. That's the next one. We have independent events. Independent events. Okay. So let's say that in economics, right, we have something we call necessity. Necessity, like some goods are necessity, like no matter the price you buy it. So in a situation like that, the probability that you buy a necessary good, all right, is independent of the changes in prices. Because if a good is a necessity, no matter the price you buy, like if they are the basic needs of life, you buy it. So that's a clear example. All right. So let's look at here. We say that two events are independent if the probability of one event is unchanged if the other has occurred. So two events A and B are independent if and only if probability of A based on B is equal to probability of A, right? Probability of A based on B is equal to probability of A. Okay. So let me say let me illustrate what I'm saying. So in probability, note that if I want to say probability of A based on B, we use it. So probability of A slash. So this slash means based on B. All right. Is equal to probability of A. Now this here simply shows that A is not dependent on B, because if the probability of A depending on B is the same as probability of A standing alone, it means that it doesn't really depend on B. But assuming probability of A based on B is not equal to, or if it is different from probability of A alone, then we will say that the probability of A depends on B, right? But once probability of A depending on B is just the same as probability of A, then it doesn't really depend on B, because even if it stands alone, it's just the same as it depending on B, all right? So that is the issue of independent events. All right. Now, also another instance where two events are independent is when, like, probability of, so that's the first instance. I've explained that. Another instance is that if two events are independent, let's say probability of A and probability of B are independent, all right? They don't depend on each other. It means that one occurring will not really stop the other from occurring. All right. It means that one occurring, like, unlike this one, unlike mutually exclusive, that one, when one occurs, the other cannot occur. I mean, the occurrence of one stops the other from occurring. But when we talk about independent in that sense, or in that scene, for independent events, when one occurs, it doesn't stop the other from occurring. All right. So then we can also say that in another vein, another way of explaining independent events is that for independent events, the two of them can occur at the same time, all right? Because one occurring doesn't stop the other from occurring. Now, in essence, it means that when two events are independent, it means that the two of them can occur at the same time. And in probability, when A and B occur, the word "and" in probability is denoted by the intersection, all right, here. So the word "and" here is denoted by the intersection, this one, A and B. That means that the two of them can occur at the same time, because one occurring doesn't stop the other from occurring, all right? Let's look at this scenario. So, and of course, "and" in probability means multiplication, okay? So let's look at this scenario. Now, A bag contains 5 red oranges and 7 green oranges. An orange is drawn from the bag and the color noted, and the orange is replaced. A second orange is drawn from the bag. Find the probability that the first is red and then the second is green. So the word end, A-N-D, end here simply shows that they are independent of each other, because this and this can occur, right? They are independent of each other. So let's look at the question. Where the question says that there are 5 red oranges, 7 green oranges. There are 5 red oranges and 7 green oranges, right? If the oranges are drawn one after the other, find the probability that, and the question says, and it is replaced. Find the probability that the first is red and the second is green. The first is red and then the second is green. The first is red and then the second is green. So we have a basket of oranges, right? We have a basket of oranges. Find the probability that. Now, let's note that the question says that the red oranges are 5 and then the green are 7, right? The red are 5, the green are 7. So it means that the total oranges is 12, right? Now the question says that 2 oranges are picked. What's the probability that the first is red, right? What's the probability that the first is red and the second is green? If they are replaced, keep that in mind. Now we want to find the probability of the first is red and the second is green. Now I told you that and in probability means multiplication. So we are looking at probability of red multiplying probability of what? Green. Okay. Now the question says it is replaced. We replace it. So probability of red would have been 7/12. Oh, the red balls are rather 5. Sorry. The red balls are rather 5. So it is 5/12. Okay. Then the probability of green. The question says it is replaced. So it means that when we pick the first red ball, we send it back. Okay. So the total is still 12 and the probability of green is 7. All right. So probability of red and green would then give us 5/12 times 7/12. Okay, and we have the answer. All right, 5/12 times 7/12, then we have the answer. Now, on the assumption that the question said that it is not replaced, what would have then happened is that the first red, probability of red, would have been 5/12. But if it is without replacing, it means that we don't send the red ball back. So if you want to find probability of green, the total will now be 11. Okay. The total will now be 11. The green is still 7. Okay. Because if it is without replacement, without replacement. Yeah. Okay. So that is it about the independent event. Then also we have dependent event or conditional event. Now, dependent event simply is a scenario where the occurrence of one event depends on the other. It is when the occurrence of one event depends on the other. So let's say somebody will say the probability that I'll come to campus depends on me getting money to come. It is a clear example of a dependent event, because dependent event simply means probability of A occurring given that, or based on the fact that B has what? occurred. Probability of A occurring based on the fact that B has occurred. That is the issue of dependent event. All right. That is the issue of dependent event. That is the issue of dependent event. Okay. Now, if events are dependent, okay, there is also a formula for that, for dependent event. Now, if probability of A depends on probability of B and they are indeed dependent, okay, I mean, if they were independent, the answer would have been probability of A, of course. That's for independence. But if they are dependent, probability of A, given that B has occurred, will be equal to probability of A intersection B divided by probability of B, all right, which is the same as probability of A times probability of B over probability of B. Okay. All right. So let's look at this scenario. Yeah. All right. So yes, so let's look at this scenario. A group of 20 university students were classified by sex and by their major subjects in the table below. So we have accounting, 8 male, 2 female, procurement, 4 male, 6 female. All right. Now here, what it means is that there are a total of 10 accounting students, because for accounting students, there are 8 male, 2 female. Then also there are a total of 10 procurement students, because there are 4 male and 6 female. There are 4 male and 6 female. So if a student is chosen at random, so please always watch the preamble. I think I told you this when I began. So if a student is chosen at random from the group, what is the probability that the student is a female? A, given that the student takes procurement. All right. So if a student is chosen at random from the group, what is the probability that the student is a female, given that the student takes procurement? All right. Given that the student takes procurement. Now here, what will happen is that we have to, first of all, we are looking for probability of female based on procurement. Probability of female based on procurement, right? So I already told you that for the conditional probabilities, probability of female based on procurement will be probability of female intersection procurement over probability of what? Procurement. Right? Probability of female based on procurement with probability of female intersection procurement divided by probability of what? Procurement. So if a student is chosen at random, so in the question, the probability of female, okay, the question says if a student is chosen at random. So in the question, probability of choosing a female, because if you watch here, we have 2 female accounting, 6 female procurement. So there are a total of 8 females, right? There are a total of 8 females. There are a total of 8 females. So here, sorry. So probability of female will be 8 over 20, because there are a total of 8 female. Then probability of procurement, I think procurement, there are a total of 10 procurement, right? A total of 10 procurement. There are a total of 10 procurement. So yeah, so 4 plus 6 is 10. So there are a total of 10 procurement. There are a total of 10 procurement. So that would have been 10 over 20. Okay. But if you want to find female end procurement, that's probability of female end procurement. Okay. The probability that the person is a female and the person is doing procurement, that is this space. That is 6. So female end procurement, the intersection is what? 6. The intersection is 6. So female end procurement is 6 over 20. So per our formula, female intersection procurement is 6 over 20. That is the numerator. And then probability of finding procurement itself will be what? 10 over what? 20. Okay, and that is the answer. All right, that is the answer. Okay, so what do we get? Those of you having calculators. Okay, so that's 3 over 5. All right. Now let's take another scenario for you to get better. Let's look at the B. Find the probability that the student is a female, given that the student takes accounting. So that's probability of female based on accounting. The formula will be probability of female intersection accounting. So female intersection accounting is 2. All right, it's just 2 over 20. Then the denominator per the formula will be probability of what? Accounting, which is what? Accounting, we have a total of 8 plus 2, which is 10. All right. So that'll be 10 over the total, which is what? 20. So you have 10 over 20. When you divide, you will get 1 over 5. Okay. All right. So these things are a little straightforward. Now, let's come to probability tree. Then we will talk about the Bayes theorem. And then we may end it for today after probability tree and then the Bayes theorem, then we will end for today. All right. Now, for the probability tree, okay, I'll teach this simple example. Then I'll use a difficult illustration. Then we'll go to Bayes theorem. So the illustration I'll give, I will not finish solving all the illustration. I told you already that at the end of every meeting, you get an assignment. Then we are taking all the assignment when you come. So the earlier I know you are supposed to report to campus on Tuesday. So all the assignments will be taken on Wednesday. Okay. So the earlier you do them, the better for you. All right. So let's look at this scenario. Probability tree. A bag contains 8 white counters and 3 black counters. 2 counters are drawn one after the other. Find the probability of drawing 1 black and 1 white in any order given. Find the probability of drawing 1 black and 1 white in any order. So it can mean that the first is black, the second is white, or the first is white, the second is black. It says in any order. All right. Given that the first counter is replaced, or given that the first counter is not replaced. Okay. So here we have 8 white and 3 black. Okay, 8 white and 3 black. So it means that we have a total, which is 11. 8 white and 3 black. Please, if you have a question, just raise your hand. I think there is an option for you to raise your hand, and I'll let you ask your question. Okay. All right. So yes. So here, a total here 8 We have 8 black and 3 white, right? If I remember, I think I have to be switching between the questions, but I think, yeah. So 8 white and 3 black. Okay. Now we are drawing 2 counters, all right? And let's say the first counter is replaced. Yes, so the question says that somebody is saying, can I repeat myself again? So we are doing a probability tree question, and I'm saying that the question says that we are drawing in a box. There are 8 white counters, so there are 8 white, and then 3 black. Then the question says that we are choosing 2 counters in any order. So it can mean that the first is white, the second is black, or the first is black, the second is white. Okay, that's the meaning of in any order. All right, then the first part of the question says that what will happen if it has replacement? What will happen if it has replacement? Okay, so I'm saying that with replacement, it means that when we pick the first one, we send it back. All right, so here in drawing the tree, we have probability of white. Okay, of course it will be, because there are 8, so we have white 8 white counted, so it will be 8/11. All right, and please, at this level, you shouldn't be asking why 8/11. I think by now you should know why, because we have a total of 11. The probability of picking white is 8/11 because we have 8 white counters. Okay, now if it is with replacement, in our second pick, we can pick another white, which is what? 8/11. Or we can now pick a black, which is 3/11. Okay, so that's the first pick here. Then the second pick can be either white or black. Let's assume that our first pick is rather black. So probability of black is 3/11. Okay, then after picking black, we can pick a second one, which is white. So probability of white will be 8/11, and probability of another black will be 3/11. Please, it's like this because we are doing with replacement. So once we pick, we send it back. So the figures don't change. All right. Now the question says that find the probability of picking 1 black or 1 white in any order. So this simply means that we can pick a black and a white, okay, or we can pick a white and a black, okay. So that's picking 1 white, 1 black in any given order, Okay, so looking at this, probability of white, black and white is, we go so along this lane. So black is 3/11 and white is 8/11. So that's probability of black and white. Or means plus. So plus probability of white and black. So white 8/11 and black. So we go here. So probability of white 8/11, come down here, black 3/11. Okay. So always know that the end or intersection means multiplication. I think I've already told you that. All right. So that is how we solve this question. Now, on the assumption that the question said without replacement, the answers will change a little. Now, if the question is without replacement, it means that when we pick, we don't send back. So the first one, probability of white will be 8/11, okay? But when we don't send this white back, it means that the total left is now 10 instead of 11. So the probability of another white, so now the white remaining is 7 because we are not sending the white back. So probability of another white will be 7/10 because the total of whites remaining is 7, and then the total of 11 is now 10 because we have not sent the white back. Okay. But when we are picking black instead, the black has not changed. The black is still 7. The black is still 3. All right, it hasn't changed. but the total is now 10, not 11, because the one white has left. So it means the total is now 10. So we have 3/10. Okay. But if you rather start with black, that's probability of black will be 3/11. But after choosing black, if we don't send the black back and we are picking another black, it will now be 2/10 because we are not sending the black back again. But if we pick a first black and we are instead picking a second white, probability of the second white will be 8/10 because the white is still 8, but the total is now what? 10. All right. Now, per the question said that we should find the probability of a white and a black in any given order. So it means probability of white and black or probability of black and white. So probability of white and black will be here. So we go here, white and black. So we have 8/11 times 3/10. The or here means plus black and white. So black, we come here, black, which is 3/11, and then white, which is what? 8/10. So that is how we find it. That is how we find it. All right. That is how we find it. So that is it about the probability tree. Okay. That is it about the probability tree. So the answers are in the slides. You can just look at it and then we move on. Okay. Now I told you I'll give you an assignment. So the assignment is on probability tree. Okay, it's here. So when I finish, I'll forward this thing to your coursework, and then you are supposed to solve it. All right. Now I'll do you a favor of explaining it to you. I'll do you a favor of explaining it to you, but I'll not draw anything for you, but I'll do you a favor of explaining it to you. I want to see whether you can solve this. Okay. Now the question says that a company has installed a new computer system and some employees are having difficulty logging on to the system. They have been given training and the problems which arose during the training were recorded and the probabilities calculated as follows. An employee has a probability of 0.9 logging on successfully on the first attempt. So put that in your mind. If an employee is logging on to a system, okay, on the first attempt, the employee has a probability of logging on 0.9 successfully, which also means that on the first attempt, there's a probability of 0.1 of not logging on successfully. Because on the first attempt, he has a probability of 0.9 logging on successfully. That means that he has a probability of 0.1 of not logging on successfully on the first attempt. Now the question says that if the employee logs on and is successful, then the employee will also be successful on each later attempt with 0.9 probability. So here, what they are saying is that if the employee logs on successfully on any attempt, it means that the next time he's logging in, okay, the probability of success is 0.9, all right? But the third one says that if the employee logs on and is not successful, he loses confidence, and then the probability of a successful login on later drops to 0.5. So look at the scenario. An employee has a probability of logging on successfully 0.9 on the first attempt. All right. Anytime he's successful, the next probability of success is 0.9. But anytime he is not successful, the next probability of success is 0.5. So put this in mind. When he logs, the first attempt, when he logs on, he will have 0.9 success. Anytime he's successful, the next attempt of logging in, he will also have another 0.9 success. But if he's unsuccessful, the next time of logging in, he will have 0.5% or 0.5 probability of what? Success. All right. Yeah. So as I told you, I'll do you a favor of explaining the question to you, but the others there you have to get it solved. So here, the probability of success is 0.9. That's the first attempt. That means that if you want to find the probability of failure for the first attempt is 0.10. Okay, is 0.1. The question says that if at any time he's successful, the probability of success on the next attempt is 0.9. So it means that here he's successful, right? The probability of the next success is 0.9. That means that the other side is always not given. So you have to know. So the probability of failure is 0.1. But the question says that if at any time he logs in and is not successful, the probability of the next success is 0.5. So here, if he fails, like here, this line, it means that the probability of the next success will rather be 0.5, not 0.9. Then, of course, the other side, the failure, will be 0.5 as well because they must sum up to 1. Now, if I want to extend this line, okay, this line here, there is still success, like this line here is still success. So if I want to extend it again, because it's still success, probability of success will be 0.9, and then probability of failure will be 0.1 for this line. But for this line here, because it's a failure, probability of success will be 0.5. And probability of failure, of course, will be 0.5. Now let's come to this one, this line. This line, because it's success, the probability of another success will be 0.9. Then the probability of failure will be 0.1. And the last one here, because it is a failure, probability of a success will be 0.5. Then probability of a failure will be 0.5. Okay? Yeah, so we have a very nice tree. So I have drawn the tree for you. So I have drawn the tree for you. You are supposed to go and do the rest. The question says that use tree diagram to find the following. An employee successfully logs on in each of the 3 attempts, all right? Successfully logs on in each of the 3 attempts. So it means that we have success, success, success. And I think this one you should be able to do it. I won't show you. I mean, 3 attempts, all of them is successful. So success, success, success. You should be able to do it. You should also know which line to follow, all right? Then the second one is, he fails in the first, but is successful in the next 2. So fails in the first, successful in the next 2. So we have success, failure, failure. All right. So that is it. So please, I virtually solved it for you, but go and solve it and submit on Wednesday, I've told you. Then C, an employee logs on successfully only once in 3 attempts. So this one is a technical one. He logs on successful only once in 3 attempts. So here, there will be 3 forms of the answer, you add it. He logs on successfully only once. All right, so it can be something, 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 or something, 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 or something, something. Then you have to add it because of the or, right? So go and solve the rest. Now you end today's meeting by doing the Bayes theorem. All right, you end today's meeting by solving Bayes theorem. We will end today's meeting by solving Bayes theorem. All right. You end today's meeting by solving the Bayes theorem. Now, Bayes theorem is a concept which we use to solve reverse conditional probabilities, all right? Reverse conditional probabilities. And I always try to use probability tree to solve the Bayes theorem so that we get it better, all right? Now here, let's look at this question. 3 girls, Selom, Fafali, and Enyunam pack biscuits. So S, F, and E. They pack biscuits in a factory Ceylon packs 55%, Fafali packs 30, and then Enyunam packs 15, right? The probability that Ceylon, Fafali, and Enyunam, they break biscuit while packing is 0.7, 0.2, and 0.1. Okay. Now here, Fafali 55, oh sorry, Ceylon 55, Fafali 30, Enyunam 15. So Ceylon 55. So here, probability of Ceylon 55%, probability of Fafali, I have to just be going back. So Fafali is 30, Enyunam is 15. So Fafali is 30, and Enyunam is 15, right? Now the question says that the probability that Ceylon packs, let me go to the question. Let me not read from my mind. So here, the probability that Ceylon, Fafali, and Enyunam break biscuit in packing are 0.7, 0.2, and 0.1. All right. So the fact that a biscuit will break, so probability of the biscuit breaking, based on the fact that it was packed by Ceylon, is 0.7. The probability that the biscuit was breaking, based on the fact that it was packed by Fafali, is 0.2. And the probability that the biscuit will break, based on the fact that it was packed by Enyunam, is 0.10. All right. So we should be able to simply illustrate this on a probability tree. All right. We should be able to simply illustrate this on a probability tree. We should be able to illustrate this on a probability tree, which we will do so very soon. All right. So probability that Ceylon is packing is 0.55, right? Probability that Fafali is packing is 0.3. Probability that Enyunam is packing is 0.15, right? Now, probability that the biscuit will break based on the fact that Ceylon is the one packed is 0.7. So probability of breaking based on Ceylon, right? Because this is the Ceylon's line is 0.7, which also means that the probability that it will not break based on Ceylon, will be 0.30. The other side. I always tell you that probabilities, we don't give the other side, you are supposed to know it. So we also have here probability that it will break based on Fafali is 0.2. So probability that it will break based on Fafali is 0.2. Then probability that it will not break, which is not given, but you are supposed to know, to not break based on Fafali is 0.80. That's the other side. Then finally, probability that it will break based on Enyunam is 0.1. That means the probability that it will not break based on Enyunam is 0.9. Okay. Now the question says that the question says that what is the probability that a packet of broken biscuit found by the checker was packed by Ceylon? Now, all along, we found the question gave probability of breaking based on whether it's Ceylon, Fafali, or Enyunam. But here, the question now says that what is the probability that a packet of biscuits a packet of broken biscuits was found by the checker? What's the probability that it was packed by Ceylon? So now we have broken, but what's the probability that it was packed by Ceylon? So the question is asking us that. So here we see that the question has given the broken to be the prior probability, right? The broken. Because what's the probability that a packet of broken biscuit found by the checker was packed by Ceylon? So in this instance, the broken is the prior probability. and then the Selom is the posterior or the subsequent probability. So what is the probability that a packet of broken biscuit found by the checker was packed by Selom? So now we have broken, but we are trying to see whether Selom is now based on what? The broken, right? But all along in the question, we have broken based on Selom. So this is a clear example of Bayes' theorem, because Bayes' theorem helps us to find a reverse conditional probability. It helps us to find a reverse conditional probability. All right. So we already have broken based on Selom, but the question is asking us to find Selom based on broken. Right. Question is asking us to find Selom based on broken. That is what we are going to do now. Okay. Now we all know from our basic probability, if you remember, we all know that the probability that a broken biscuit can be that it is coming from Selom or Fafali or Enyunam, right? So the probability of a broken biscuit can be from Selom. So if the Selom is the one who broke it, it will be Selom, like Selom and broken, right? So we have probability of broken based on Selom times probability of what? Selom, okay? Because before you get to the fact that a broken biscuit was packed by Selom, we have to first of all, it has to be first of all Selom who packed it. Then it was gotten, or it got broken. All right. So it is this and this. That's why I'm multiplying it. Or means plus. Or it was rather packed by Fafali. So we have probability of broken based on Fafali times probability of Fafali, right? Or that's plus. It is broken by Enyunam. So probability of broken based on Enyunam times probability of Enyunam, right? Because we can't get here without getting we can't get to probability of broken based on Enyunam without starting with probability of Enyunam. So it is this and this. That's why I'm multiplying, right? So you have, that will be the probability of broken. But now the question says a broken biscuit is found. What is the probability that it is coming from Selom, right? So the total sample space is this or this or this. But then if you want to see whether it is coming from Selom specifically, then the Selom one will be what? The numerator, like what we've always been doing. So probability of Selom based on broken will be probability of broken based on Selom times probability of what? Selom. That will be the numerator. So I'm taking this one to be the numerator. That's the likely way Selom can break it, divided by the total sample space that anyone can break it. So probability of what? Breaking. All right, and this probability of breaking, its expansion is here. It's here. There's the expansion, okay? So mathematically, this will give us 0.70 times 0.55, okay? Divided by 0.70 times 0.55 plus Fafali or so. So that will be 0.20 times 0.30, right? Plus Enyunam will be 0.10 times 0.115. Okay. Okay. If the question was rather looking for Enyunam, then the Enyunam one, this last term here will be the numerator. If the question was rather looking for Fafali, the middle term here will be the numerator. But the question is looking for Selom, so that's why the Selom is the numerator. Okay. So that is the Bayes theorem. That is the issue of Bayes theorem, all right? Okay, so I mean, the answers are here in the slides, and there's another example which I expect you to go and try, okay? So I'll end the class here. I wish you could ask questions, but I have to stop this class and join another class for the beard management at 9 o'clock. So I'll end here. I'll send you the recording of the meeting. So we are done up to base theorem. Tomorrow we start with expectations, then enter into probability distributions. Then we end probability tomorrow, all right? Then subsequently, whether on the weekend or probably next week, we will decide, and you have tutorials on probability, okay? All right, so the recording, the course rep should just send me one email that I can forward the recording to, then you can now distribute. The size will not allow us to share it on WhatsApp, so the email will work, so that maybe if you have a Telegram group, the course rep can put it on the Telegram group because it can take more than 25 megabytes. So you get that, and you get the assignment as well. And then you meet, God willing, same time tomorrow, all right? So please tell your colleagues that they should join the class. And then, as I told you, everything is considered taught, all right? So you have a nice day, and then we'll meet tomorrow. So you get a recording, okay? So tomorrow, before we start, you have any questions, you can ask, all right? So have a nice day.